Welcome to digital learning platform of Shri Guru Sudhendra College, course BCA second semester, subject mathematics, and the topic is algebra of complex numbers. So first consider two complex numbers, let it be z1 and z2. So z1 is equals to x1 plus iy1 and z2 is equals to x2 plus iy2, where x1, x2, y1, y2 belongs to capital letter R. Here R denotes set of all real numbers. Then first one z1 plus z2, that is addition of two complex numbers, that's equals to x1 plus iy1 plus x2 plus iy2. So first consider the real part, that is x1 plus x2, and the imaginary parts, that is iy1 plus iy2. So here I is common, I into y1 plus y2, that's equals to x plus iy, because consider x1 plus x2 as x, I as it is, and y1 plus y2 as y, where x1 plus x2 is equals to x and y1 plus y2 is equals to y. Second one z1 minus z2, that is subtraction of two complex numbers. So x1 plus iy1 minus x2 plus iy2. So multiply this minus sign, that will be x1 plus iy1 minus x2. So minus into plus, that is minus iy2. Now first thing is real part, so x1 minus x2 plus I into iy1 minus iy2. So I is common, so I into y1 minus y2, directly x dash plus iy dash. Here x1 minus x2 is equals to x dash and y1 minus y2 is equals to y dash. Next, third one, multiplication of two complex numbers, that is z1 into z2. That's equals to x1 plus iy1 plus into x2 plus iy2. Okay, so multiply these two, we get x1 into x2 plus x1 into iy2 plus second term iy1 into x2 plus iy1 into iy2. So that will be x1 plus x2 y1 into y2 I square, is it? So iy1 into iy2, that will be I square into y1 y2. Okay, so we know that square root of minus 1 is equals to I, and I square is minus 1. So directly x1 into x2 minus y1 into y2 plus I into x1 y2 plus I into x2 y1, because I square is equals to minus 1. Now x1 plus x2 minus y1 plus y2 is equals to, here I is common, so I into x1 y2 plus x2 y1. So consider x1 x2 minus y1 y2 as x3 and x1 y2 plus x2 y1 as y3. So that will be x3 plus iy3. And the last one, z1 divided by z2, that is division of two complex numbers. So that is x1 plus iy1 divided by x2 plus iy2. The condition is z2 is not equals to 0. If z2 is equals to 0, we can't divide the complex number. Okay. Now, so x1 plus iy1 divided by x2 plus iy2. Now consider the conjugate of the denominator term. So the denominator term is x2 plus iy2. So its conjugate is x2 minus iy2. So multiply this conjugate of the denominator term to numerator and denominator. Okay, so we get x1 plus iy1 into x2 minus iy2 divided by x2 plus iy2 into x2 minus iy2. So multiply the terms. X1 x2 plus y1 y2 plus I into x2 y1 minus x1 y2 divided by x2 square plus y2 square. So when we multiply these two complex numbers, we get x2 square plus y2 square. That's equals to x1 x2 plus y1 y2 divided by x2 square plus y2 square plus I into x2 y1 minus x1 y2 divided by x2 square plus y2 square. Okay, so consider this term as x4 and this term as y4. We get x4 plus iy4, that is where x1 x2 plus y1 y2 divided by x2 square plus y2 square, that's equals to x4, and x2 y1 minus x1 y2 divided by x2 square plus y2 square, that's equals to y4. Thus, if z1 z2 are two complex numbers, then z1 plus z2, z1 minus z2, z1 into z2 and z1 divided by z2, the condition is z2 is not equals to 0, are all complex numbers. The additive identity element is 0 plus I into 0 and the multiplicative identity element is 1 plus I into 0. And in the complex number, the additive inverse of z is minus z and the multiplicative inverse of z is 1 by z. Here z is not equals to 0. So these are the algebra of complex numbers. Thank you.